Alright, physics, here we are. This is from homework 3. This is problem 5. So this is going to be analyzing a circuit. So we've got a lot of things to figure out about this circuit. So let's start with step What are we looking for? And what units do we expect it to have? So first, the equivalent resistance seen by the battery. Req is something in ohms. The current leaving the battery. I is going to be something in amps. The power used by the entire circuit. P is going to be something with units of watts. The voltage drop across each resistor. So we're going to be looking for V for each of the resistors. That'll be something in units of volts. The current through each resistor. So lots of things to figure out there. I is equal to something in amps. And finally, the power used by each resistor. P is equal to something in watts. So those are all the things we're going to be looking for. This is going to take quite a while. This is going to be a bit of a doozy of a video. This will probably be a couple of videos. So where do we begin with this circuit? First, let's see. We have R1 and R2 in parallel with each other. And that is in series with R3 and R4, which are in parallel with each other. So let's start to simplify this. We'll take these guys, and we'll use our formula for equivalent resistance of resistors in parallel. So in this case, it's going to be 1 over R1 plus 1 over R2, and we want the inverse of that. So 1 over 25 ohms plus 1 over 50 ohms. Don't forget to take the inverse of that at the end. That's going to give us 16.6 repeating ohms is the equivalent resistance of those guys. So now let's do it to the other guys too. So Req for these guys is going to be 1 over 50 ohms plus 1 over 75 ohms. And we want the inverse of that. So if you do all that, this is going to give us an equivalent resistance for these guys of 30 ohms. Alright, so now I have a slightly simpler circuit. So don't be lazy, redraw your circuit. So that's my voltage. This is my first equivalent resistance. That is my second one. So V is still 18 volts. This Req is 16.6 ohms. And this Req is 30 ohms. So this got a little bit simpler, but we can do even more. I've got 2 resistors that are in series. So I can simplify that guy too, and that is going to give me if I simplify those resistors in series, that's just going to end up being 46.6 repeating ohms. V is still 18 volts. So I've got that. So that is actually one of my answers. The equivalent resistance of this whole thing. So my answer for A is 46.6 repeating ohms. Call it 46.7. The next thing I want is the current leaving the battery. Let me change colors because I can. So I know the voltage, I know the equivalent resistance. Getting the current leaving this battery is going to be easy. This is just Ohm's law. V equals IR. That's going to give me I is equal to V over R. And in this case, it's really R equivalent. So I is equal to, our voltage is 18 volts. R equivalent, we just figured out, 46.6 repeating ohms. Ask my calculator, and that's going to give me 0.3857 amps. So I'm keeping a couple of extra digits because there's a lot of, I'm going to use this number again and again throughout this. I don't want to do too much rounding, so I'm keeping an extra place there. So that is actually my answer for B. For part C, well, let's keep switching colors. Make this nice and pretty. For part C, what's the power used by this entire circuit? This is easy. This is just going to be Watt's law. P equals IV. And I just figured out that I is 0.3857 amps, and V is the 18 volts. That is the voltage being provided by my battery. So put that in the calculator. P ends up being 6.943 watts. So this whole thing, all four of those resistors all working at once, it's going to end up using 6.943 watts. So now on to the harder parts. We have to figure out the voltage drop across each resistor. Okay, so what we're going to do for that, let's keep in mind this first simplified circuit here. This guy, and we'll go to a new screen and do that guy again. So in that case, I have my battery like that. And my two REQs. So V is 18 volts. This equivalent resistance, REQ, this guy was 16.6 repeating ohms. And this guy here, this guy was 30 ohms. Alright, so to figure out what's the voltage across each of these equivalent resistances, this is just going to be Ohm's law. So for the top one, to figure out what that's going to be, V is IREQ. Well, we just figured out that I was 3857 amps, and that top resistance, that one was 16.6 repeating ohms. So plug that into the calculator. The voltage I have across those guys, 6.428 volts. So the voltage up here, 6.428 volts. For the bottom one, or for this other equivalent resistance, so the voltage here, V is IREQ. Alright, notice these guys are in series, which means whatever current is leaving the battery and going through this, the first REQ, is also going through this second REQ. So 0.3857 amps. This second equivalent resistance is 30 ohms. So put that in the calculator, and we're going to end up with a voltage of 11.571 volts. So this voltage here, 11.571 volts. Gotta have the units. So you may notice something that's kind of important here. If I add those numbers up, 11.571 plus 6.428, and I ignore the fact that there's a little bit of rounding in there, that adds up to 18 volts, which it has to. The voltage being provided by the battery, I need to have that same amount of total voltage drop across both of these resistors. So I've got that. Now let's take that idea. So I think that was my answer for Oop. Skip that. Let's take that idea and apply it back to our original circuit. So it'll take me a second to redraw this. There's our battery. There's our 1. There's our 2. Our 3. And our 4. So V is 18 volts. R1, 25 ohms. R2, 50 ohms. R3 is also 50 ohms. And R4 is 75 ohms. So I'll actually pause this here because this video is getting a little bit long, and then we'll pick it up in just a minute.